A very warm welcome to Dr. Mohan and all the participants of the program and also the PALS team. This is the third day of this FDP program, which is primarily from IBM folks. And as you know, Mr. Mohan is also an IBM person. He has been with IBM for 38.5 years. Though he's not working with IBM now, he is superannuated, but he's also one of the IBM folks. So, and a very short biodata of Dr. Mohan. He's an alumnus of IIT Madras. He passed his BTech in 1977. Then he did his PhD from University of Austin in US. And then he joined IBM in San Jose or San Jose, as you see pronounced in India. And he has been there for, as I said, for 38.5 years and done a lot of contribution, not only to IBM and its products, but to the computer products in general. Notable among his contribution was in the area of database locks, and he was also, and most of his products were used not only by IBM, but from the other manufacturers of databases have also taken and used them. Besides, there are a lot of other products which he has worked on, and he has got a lot of fellowships and credits. He's been an IBM fellow from 1997 to 2020, a fellow of ACM. He's still a fellow of ACM. He's still a fellow of IEEE, and he has become a distinguished alumnus of IIT Madras in 2003. And to his credit, he has got 50 patents to his name. He has invented 50 patents. And that will tell you an idea of how much of efforts he has put in the field. And he has also worked in a focused manner on blockchain, AI, big data, and cloud technologies from 2015. And he has made a lot of contribution in these areas. And now post IBM, he's now a professor, a distinguished visiting professor with Tsinghua University in China. He is a member of Board of Governors of Digital University of Kerala in Thiruvananthapuram. He's also an advisor for at Tamil Nadu e-governance agency and Kerala Blockchain Academy. He's a Shaw visiting professor in National University of Singapore, and he's holding many other such distinguished credentials. And since we do not have time, of course, I can go on talking about his achievements for a very long time. But in the interest of time, I would rather have him come and talk about his vast repository of knowledge, which he wants to share with the others. I will give him an opportunity to come. But his resume and his biodata has been shared with all of you in a document, and you may go through it in detail at your leisure and get to know what a distinguished person is going to address you today. So with that, I hand over to Dr. Mohan to start his lecture on blockchain.
Thank you, RKR. I really appreciate the wonderful introduction, and I'm glad to be able to speak for the third time in a PALS event. I did it 2 months ago, back-to-back 2 days, literally 2 days after I arrived in India. On 10th of December and 11th of December, I spoke on AI and cloud database systems. So let me see, one participant can share at a time, 2 participants. Why is it not letting me? Advanced sharing options. Why is it showing me all this? Okay, sorry. Let me get rid of this window. Okay, you are able to see my
yes.
cover slide, right? So let me also close this floating window. Hide floating controls. Okay, I think we are in business now. So as RKR mentioned, I have these multiple affiliations, none of which pays me money. Of course, these are all honorary positions. And you see here a couple of QR codes. If possible, take pictures of these things, or you can find them later on also in the presentation. You will find that the links to various versions of this presentation, as well as talks on AI and cloud database systems and so on, are accessible. If you go to a spreadsheet, the link to which is behind this QR code on the left, and the one on the right is to my homepage, for which you see the URL here. And you'll find that even with the same set of slides, when I speak multiple times, I don't necessarily repeat information. And this presentation actually has tons of slides than the ones that I'm going to show now. So if you get hold of this PowerPoint presentation using the link that was already in the chat session, what you will find out is that if you go through the slides in the slideshow, you will see the slides I'll be showing now. But if you go into the edit mode, then you will be able to of the hidden slides, and they contain a lot of valuable information. So if I had all the world, I'll be covering everything that's mentioned in this slide. Basically, behind this whole presentation is to educate not only computer science people, but also non-computer science people and even non-technical people on some of the basic ideas about this topic that has become very hot in the last few years, namely the blockchain technology. And you find people across the globe, debating it, discussing it, getting excited about it. There is in some quarters even a religion associated with this technology. And there are lots of people in my backyard right here in Silicon Valley who are trying to make a lot of money with startups and venture funding and things like that. So what you'll find out through the presentation is that after some level of introduction, I'll talk about a few specific systems. In particular, I'll talk a lot about Hyperledger Fabric, which has become like a de facto standard, even though there are no standards in this business. And also, I gave a keynote speech at the ACM SIGMOD conference in Amsterdam way back in 2019. And associated with that keynote talk is an easy to read 8-page paper with something like 70 references. I highly recommend that you download that paper, and the link you see here and the QR code here is for that. And also, when I was in Singapore in the first half of last year, where I was teaching at the National University of Singapore a seminar course, I prepared a reading list for the students to choose papers from. So that reading list link is also here. And if you go there, you'll find some more papers I have in the 19 SIGMOD paper. And overall, you'll be able to get access to tons of material that will expand upon some of the topics that I'll mention very briefly. As you can imagine, this area being an active area, there are all sorts of people involved in it. As I say here, numerous organizations across the world are working on various aspects of blockchain technology. The whole field got going with the emergence of this cryptocurrency called Bitcoin that I'm sure all of you have heard about, which was talked about in a paper written by this anonymous author, Satoshi Nakamoto, more than 12 years ago. And nobody knows who the real person behind this Bitcoin idea is, and even its implementation to begin with. People don't even know whether it's one person or it's a group of people. And if you go to the Wikipedia page on Bitcoin, you'll find also some interesting things. But fundamentally, the idea was that a group of people across the globe, anonymous network, in order to just send this artificially created money called Bitcoin, send and receive Bitcoins. You might wonder, how do these things get created? So there are special transactions that can create Bitcoins, and they are done in a very stylized way. But the most important aspect of this network, the Bitcoin cryptocurrency network, is the fact that participants don't have to reveal their real world identity. And it's an amorphous network because nobody participants are there. People can come and go as they wish. But in this chaotic way, they still are do these transactions where all that the transactions are doing is send and receive Bitcoins. You might wonder, why is there such a focus on this one aspect of real world activity? And that's why I don't like it actually, because they let in random people whose antecedents they don't know. They get worried that these people might do some illegal things, or they might rewrite history. After a few transactions have executed, they could go and change the history. And even though I sent RKR 10 Bitcoins, later on, I could pretend as if I didn't actually send it to him. And, even do illegal things, send the same 10 Bitcoins to RKR as well as Ravi, things like that. That's double spend. So in order to prevent such Byzantine behavior, as it's called, there is a very costly process that the system goes through called mining, where the participants that want to be able to decide on what transactions will get executed will have to solve a math problem that's expensive in terms of computation. And the reason some participants are willing to go through that pain of solving that math problem by burning up a lot of MIPS is because if they do win this battle amongst multiple people who are concurrently trying to get this privilege of being allowed to choose the next set of transactions to be executed, then having a block of transactions, they get a reward because they won this game, if you like. And so they get a reward for being the winner, and also on a per transaction basis, there is a cost associated with getting a transaction executed. So that also contributes to the creation of money, if you like. And also this paper upfront said, as new coins get created, at some point, a limit will be reached in the paper, then new coins can be created. This is all pretty arbitrary. And in my opinion, this is all totally, bogus in the sense that these are very artificial things that have been done. The net of all that is that the number of transactions that can be executed is pathetically low. It's 7 transactions per second. And once somebody submits a transaction, for them to find out whether the transaction got successfully executed or not, it can take 10 minutes or more. And also, because of the nature of this whole beast, all sorts of illegal transactions are executed. Illegal in the sense of ransomware and prostitution and drug trafficking and all that. People converting black money or transporting black money across country boundaries and things like that. The original idea also was that, governments are bad, and wouldn't it be nice if the whole world started using a single currency, namely Bitcoin, then all the ills of society that come from different fiat currencies, these are the national currencies like rupees and dollars and so on can be gotten rid of. This is like saying the linguistic problems of the world can be solved if only everybody will speak the same language. And so, in fact, some people thought of this crazy idea and designed a language called Esperanto. Guess what? It didn't take over the world. In a similar fashion, Bitcoin hasn't taken over the world. There are many more similar kinds of cryptocurrencies that have emerged since then. So, in contrast to this kind of permissionless or a public or open network of people communicating with each other and doing transactions, what I like about the extended version of this idea is to just use the basic data structure of Bitcoin, which is the blockchain concept, but use it in an environment where you will allow only people whose identities are known and who have a reason to be part of a given network, where you can have different networks for different purposes, for different use cases. And in each network, you'll only allow those people who have a reason to be there, a good business reason, because they are participants in that business process that's represented by that network. In contrast, for instance, in Bitcoin, a single in which everybody around the world that wants to do transactions involving Bitcoin all participate. And as a result, it has these scaling problems and performance problems. Whereas by restricting, in the case of the permissioned or the private blockchain systems, participants to only the ones who have a business reason to be there, and having different networks for different business purposes, you can have far better performance. And also this idea of people trying to do bad things intentionally, the so-called Byzantine behavior, is a lot less of a problem, because here people's identity is known. Even if they try to do something, sooner than later their bad behavior will be noticed and they'll get penalized by being kicked out of the network, for instance. Whereas that's not easy to do in the case of the permissionless blockchain network. And there are also other aspects to this permissioned one that are very good, because in a world where you have GDPR and things like that, where people should be exposed to only the things that they have a reason to be exposed to on a need-to-know basis, in the case of the permissionless network, everything that's happening in the network is visible to anyone who chooses to look at the network, be part of the network, and the of the blockchain are visible. Now, what is a blockchain? So here is a graphic representation of the blockchain. It's nothing but a collection of transactions being put into a block, where a block you can think of as a page. And then over time, more and more blocks get created as new transactions are submitted to the system. And like a scheduler in a normal computer system, the miners, in the case of Bitcoin, they get to decide which of the submitted transactions will be included in the next block that gets added to the already existing chain of blocks. And in doing this, there are some extra precautions that are taken to make sure that nobody can, after a block of transactions is added, go modify the contents of that block or even delete an existing block. So if you have n blocks already, somebody cannot substitute the nth block with the n prime block, which is different, got different content, or eliminate the n minus 1 block and make the nth block point directly to n minus 2 and so on. This is because, like in cryptographic protocols, here hashing is used so that, as you see in this graphic, the nth block, in this case, let's say the third block, will contain a hash of the header of the second block. And the second block's header includes a hash of the non-header portion of that block, and so on. Okay, so it's this way of chaining together the blocks and including in each block a hash of a part of the earlier block that makes it tamper-proof. Okay, and so this is what you'll as immutability of the blockchain and tamper-proofing of the blockchain and things like that. Now, it turns out in the permissionless networks, remember I said there is a competition that some people could get involved in order to get the privilege of being able to add the next block. It's possible that simultaneously more than such person might win the competition. And so, in fact, as a result, alternate blocks might. So you might have had a chain of 3 blocks. Now suddenly, at the time when you are trying to add the 4th block, both RKR and Ravi might win this battle. And so RKR might 4th block with predecessor 3, and Ravi might add 4 prime, which is an alternate to 4, and that also points to 3. So now suddenly you can have a branching in this, what otherwise was a linear chain. This is why after a while, these separate conflicting branches might keep elongating, but there is a rule in Bitcoin whereby it says after a while, the longest branch will be declared the winner, and the other alternate branches will be declared as losers. This is the reason, as soon as your transaction gets included into a block and the block gets added to the blockchain, you cannot assume that your transaction has succeeded, because it might be in one of these alternate branches, which later on gets discarded as having been not the winning alternate branch. So there are weird things that go on in this thing. That's what's called forking and things like that. A lot of these sorts of complexities of the permissionless network don't exist in the permissioned one, because by definition, the way the privilege of adding a new block is decided in the permission networks, they don't allow for simultaneously multiple people being able to add a new block. And so for this, and also the response time is much better in that case. Those of you who are not transaction processing people should know the 7 transaction kind of thing is pathetic, because 35 years ago, our goal in the transaction processing community was to be able to do 1,000 transactions per second. In this, and with that too, with sub-second response time. In this day and age, talking about 10 minutes response time and 7 transactions per second is totally unacceptable. And in fact, when the Web 2.0 guys came into existence, they even reduced the response time expectations to tens of milliseconds, not even 1 second.
Sorry to interrupt, sir. Sir, you are reading the slide of 8 slide, or you are moving?
Yeah.
Okay, fine. Thank you.
Anyway, by this time, you should be thinking, if you are a database person, hey, doesn't this data structure called blockchain remind you of something like a recovery log in a database system? As a matter of fact, there are many similarities between the two. And so here I talk about the fact that both are append-only and hence are ever-growing, and they contain transaction-related information. But the way they are written, they are managed and all that, there are differences. The contents vary. For instance, in a traditional recovery log, which is used for the purpose of recovering from transaction failures or node failures or persistent storage failures, in order to reconstruct the database state to a consistent state, to make sure that committed transactions updates don't disappear just because they were sitting only in the buffer pool, in the volatile memory of the computer system, and so on. And because of the way the recovery log works, you could even truncate older portions of that recovery log if you have done enough backups of your database and you don't need anymore the really old versions of the log. Whereas in a blockchain, people talk about, at least for the time being, all the contents from time zero of the blockchain being kept around forever. And the blockchain is typically used as a way of keeping the history, like an audit log. And so in that sense, they think that that should be there forever. And also it's used when a new node joins the network, for that new node to now establish the state of the blockchain. It needs to go get that blockchain from another node. So for that reason also, you might need the historical version of the blockchain. And there are, I could talk about, like in the blockchain file, each transaction is described in its entirety in a contiguous way. Whereas in a typical transaction log, as transactions execute, they write log records as they do individual updates. And so over time, multiple transactions log records might get interspersed, on and on. And also, traditional database system, the locking mechanism, the database system determines how the transactions that are submitted in parallel, in what order these transactions get executed. In a blockchain system, the interleaving of transactions is determined by the miner that I talked about, or the ordering service, as it's called in some system like Hyperledger Fabric. So it's a different way in which the interspersing of transactions, or the choice of which transactions to execute when multiple transactions are awaiting to be executed varies. Okay, and also the other thing that I've said here is that in a recovery log, you only write records that describe changes being made to the database. You don't write about the reads that are performed. Whereas in the blockchain, even the reads get recorded. At least this is the case with Hyperledger Fabric. So you might ask, what's all this about? So as I said, if you think of it more like a business process or a workflow management system, the blockchain idea is a more rigorous, systematic way of doing things that used to be done in the good old days without the benefit of the blockchain concept. What are these business processes? These business processes invariably involve multiple organizations, where each of the organizations have people that are also playing different roles in that organization. They are generically called customers here, but they could be different types of roles. They could be, welders versus blacksmiths versus managers and directors and so on, right? Banking tellers versus back office people and so on and so on. So think of it as a business process where the nodes represent, the inner nodes represent organizations or units of organization, different branches of a bank or different banks working together. And what are they doing collectively? They are managing certain kinds of resources. These resources could be purely digital resources, as in the case of, let's say, Netflix and so on, where it's audio and video kinds of digital media that are being managed, or they could even represent digital representations of physical goods like diamonds and packages and food ingredients and stuff that are like spare parts and so on. So, as I said, in a permission network, participants have to reveal their identity. This relates to both people as well as organizational entities. They are authenticated, and based on the roles that these different entities play, their authorizations will be different. Mohan is allowed to approve only expense reports up to $10,000. RKR being a more senior person, he can approve $50,000. Robin is even more important, and he can approve $100,000 kind of expenses and so on. What are the assets that are being managed? As I said, they can be purely digital assets or the digital representations of physical assets. And what are the transactions in this context doing? They are causing either state transitions of these assets, where the state could be a big diamond being split into smaller diamonds, a single package being put into a bigger box, and a collection of such packages becoming the content of this bigger box. And then the bigger gets moved, and it can be put into a container, and then the container gets shipped around and so on. And then at the other end, the other reverse process will happen. The stuff that's inside this one container now gets split into multiple boxes that get shipped around separately. And then inside of each of these boxes, there are little envelopes or whatever, right? It could also be that the ownership is changing of these boxes. When I send some money to RKR, so the ownership of that particular is changing from Mohan to RKR. So these are the transactions that are happening. We talk about smart contracts. What are these things? These are nothing but traditional contracts, but the digital versions of those contracts. What do these things generally specify? You can think of them like stored procedures in a database system. They are essentially programmed ways of enforcing certain agreed upon rules of interactions, behavior, and so on. They are stylized ways, but are more formal ways of the agreed upon rules of engagement between the different participants. And so the transactions are the ones, logic is embedded within these smart contracts. There isn't a one-to-one correspondence necessarily between a transaction and a smart contract. A single smart contract could even sequentially execute multiple transactions, or a single transaction could span multiple smart contracts, okay? So these are all pretty much like traditional transaction processing, where you can, within a single transaction, invoke just a single SQL statement, or you can connect a bunch of SQL statements together and make them constitute a single transaction. And in traditional transaction systems, we talk about atomicity and all that. Even if a crash happens in the middle of the transaction execution, the transaction processing system makes sure that either all the effects of a committed transaction persist, or if the transaction did not commit, no effect of that transaction will be there. Even if some of the changes made it to disk, at restart recovery time, the incomplete transactions changes will be undone. And that's where the traditional recovery log is made use of in traditional database systems. So a ledger is nothing but a log of these transactions that got executed. And in that sense, now you can relate the ledger to the blockchain data structure that I showed you before. Each of the blocks here contains a bunch of transactions that got chosen for execution. The mere fact that a transaction got included in a block doesn't necessarily mean ultimately it will definitely succeed. It's possible that after it got included, for reasons that will become clearer later on, some of these transactions might be deemed to have not been successfully executed. And I gave you one example before, there are other examples. So it's this particular way of doing things that is different in the case of blockchain, because you are making use of now this immutable data structure which leverages hashing and such in order to make sure that you don't have certain kinds of problems that we didn't worry about in traditional transaction processing systems. So why is all this important? If you look at this picture, on the left side, you see the chaotic way in which things have been going on for a long, long time. In an import-export scenario, there are many participants across the globe who might be involved in something being sent from one manufacturer in one country to a consumer in another country. And even though they might all be using computers and doing electronic message exchanges, each of the participants has its own computer databases and programs using which it's manipulating the information regarding this import-export business, but there is no single source of truth. People also can, after the fact, make some changes which nobody else can detect that they did something illegal and so on. So there is a lot of scope for fraud and also inefficiencies, and a lot of money gets locked up in the supply chain and things like that. Okay, this is because there is a chaotic way in which these things have evolved. Whereas in the same thing, when you do it in the blockchain way, first of all, participants have to sit together and agree upon what is the modus operandi. And that's what I said is conceptualized and then implemented via smart contracts. So they have to arrive at a systematic way in which things will be done. What are the different transactions? Who can execute what transactions, under what conditions, and so on. And a single set of programs get produced, and then a single blockchain system will be made use of. And as a result, there'll be a replicated way in which things get executed. So there are many copies of the information, and there is single source of truth that gets replicated. And as a result of all this, there is a lot more efficiency, there is better bookkeeping, there is more auditability and openness and such things. Open doesn't mean everybody on earth can see these things. It's only the participants that have a reason to be part of this network that will get to see it, okay? So that's very different from in a permissionless network where anyone who has nothing else to do can be snooping around and looking at what's going on, okay? So because of this way of doing business, you'll be able to more easily track down where what happened, when it happened, and what the current state of the shipment is from A to B, like that. And it can also lower administrative expenses. The fact that you used EDI or XML in the left-hand side way of doing business doesn't guarantee that there is common agreement across all the participants as to how to interpret the contents of those EDI messages or XML messages and so on. There may be islands within which there may be understanding, but across the whole network, there may not be any common understanding of those things and such. Blockchain way of doing business, there will definitely be a much more systematic way in which these things get done, and much more granular way in which tracking will be done of who did what under what conditions. So much so that after the fact, somebody cannot claim they didn't agree to something or they didn't do this or that and so on, because there'll be all this tamper-proof way in which the tracking would have been done of what transpired in the past and such. So that's the benefit of doing things this way. You might wonder, so what's all this about? If you are a computer kind of person and you are looking at it, there are three major aspects to what a blockchain software stack looks like. One is the smart contract execution engine. There are various restrictions based on which blockchain system you're looking at as to in what language you have to code these smart contracts, what constructs are allowed in such a smart contract. They may not permit everything that a normal program might permit you to do. It'll become clearer later as to why that's the case, because any kind of non-determinism could get you into trouble. Looking up certain information, if it's done where that information could appear to be different at different times, could cause problems. The other one is, what is the data structure or the database mechanism or database system that you make use of in order to track persistently the states of the assets that I talked about. Who currently owns this piece of information or this object? And when the transfer happens, who now gets that object? All of that kind of information has to be tracked in a persistent way. So in spite of failures and all that, this information will be available and will be recoverable and all that, right? So that's where different systems have chosen to do different things, as you will see. And then there is this other one, which is in a normal transaction processing system, will be like the scheduler, which is the one that looks at the incoming transactions that are being submitted and then deciding which ones to start executing when. And then I also told you the locking mechanism in a traditional database system will determine when are submitted in parallel, in what order they get interleaved, so that there isn't any chaos, consistency and all that is not lost. In a blockchain system, that's called the consensus layer. This is the one where I was saying, in the case of the permissionless blockchain system like Bitcoin, they use what's called the proof of work, which is that math problem solving game that's played in order for different people who are aspiring to be the ones that get the privilege of adding the next block of transactions have to undergo. And that's the one where I said they waste a lot of energy solving these math problems, where people have even built specialized hardware for doing that. And there have been server farms that had come into existence in places like China. People also look for places where electricity is cheap and such in order to do all this silly stuff. I call it silly because their goal is to win this battle and thereby make a few Bitcoins. And then, as you have seen in the real world, these Bitcoin prices are speculated upon. It's become like a totally bogus kind of activity. There is no real value behind it. These are not based on any real world goods and services, but it's more based on speculation. It's like a pyramid scheme and so on. But in any, there are different consensus protocols, variations of things like proof of work, proof of stake, proof of asset and such. Also, there are other schemes where which are much more efficient, something called PBFT, which, for instance, Hyperledger Fabric used, which is a way of collection of nodes trying to come to a common understanding by exchanging messages. The variation of such things in the past that I have had the privilege of working on 40 years ago was what's called two-phase commit protocol, a variation of which assumed about is. So in any case, if you look at things like this in a blockchain system, there are various other aspects of the architecture of such a system where different designers have made different choices. It's more chaotic than the way relational database systems evolved. And so relational database systems evolved for the most part with research people doing a lot of the initial work, and then people got involved. Whereas in the case of blockchain system, bulk of the activity has happened more in the industry space than in an academic or even industrial research setting. And as a result, lots of ad hoc choices have been made with respect to various aspects of the design of such systems. And so there is scope for a lot more systematic work to be done here, more for the research kind of minded people to get involved and do things. And there are some preliminary steps that have been taken to catalog and try to rationalize after the fact why certain system designers made certain choices in preference to other choices that they could have made. So if you look at this picture, it tries to demonstrate how in the context of Hyperledger Fabric, the execution of a transaction happens. As I said before, a smart contract is the one that involves executing blockchain transactions. And it's nothing but just like a traditional SQL application. When you invoke a smart contract, when you invoke a blockchain transaction, that then causes a smart contract to be invoked with some input parameters. And what does a smart contract do? It does some database accesses in order to fetch information about the assets whose states it wants to change, or it might just be wanting to read the current state of an asset. And so depending on the transaction that's being performed, it might be a purely read transaction, or it might be a read and write transaction. Similar to SQL select versus SQL insert, delete, update kind of statements, right? In this particular case, it turns out when a contract, when a blockchain transaction is submitted, like this client is submitting, the stylized way in which Hyperledger Fabric works, first the transaction is sent to more than one endorsing peer. Think of these as like somebody is trying to get married to somebody. The two endorsing peers in such a case could be the bride and the groom. And so you can think of this client like the priest asking the bride and the groom, hey, are you willing to marry the other person? And depending on the answer that comes back, this client might then say, okay, there is agreement between the two of them. Now I'm going to submit this transaction to be actually executed. Let that marriage happen in a formal sense. So in the more general case, what happens is that the endorsing peer simulates the execution of the transaction. That's what this picture is showing. This is just showing one node, one peer, that's an endorsing peer. It will do the reads from the database, but the writes, it won't actually perform them right then, but it will figure out what the updates are that are intended to be performed. And that's what's called the write set. And what is read from the database is called the read set. It simulates the execution of the transaction and figures out what data is being read from the blockchain database store and what updates this transaction would like to perform if it were to be actually ultimately deemed to be successful, because you are actually trying to get this agreement, right? Until it's known that everybody that has been asked to endorse the transaction are in agreement to execute it, that transaction cannot be submitted for its final execution. So the read sets and the write sets from however many endorsing peers the transaction was submitted to come back to the client. And if the client finds that there is agreement, then it packages these endorsing peers read and write sets and sends it to the ordering service. The ordering service is receiving many such transactions that have been submitted, and after they got simulated their read and write sets. Now the transactions ordering service takes these multiple transactions that have come its way and it just puts them into a new block in some random order. It doesn't necessarily use any sensible, efficiency or any such kind of criterion it uses to order these transactions. Then it's now sends to all the nodes, even the non-endorsing peers. The distinction being, it's only in the endorsing peers that you have the smart contracts, also called chain code in the case of Hyperledger Fabric. The committing peers are merely there tracking the transactions as they are executed, the state changes. They may be used for analytical purposes, but they are not determining whether a transaction will get executed or not. That's the business of these endorsing peers. So when a new block of transactions arrives at these nodes, what do? They go through one transaction at a time and they check by peeping into their local database store, just like you saw the database being accessed in this picture. they will go and check for each of the elements in the read set for a given transaction, is that element still in the same state it was when it was originally read during simulation? If you find that for all the read set elements, the database is still looking the same, then it says, oh, the inputs that were used by the smart contract are still in the same state. So whatever output was generated by the smart contract can now be deemed to be valid, and hence we can now declare this transaction as being successfully executable. And so they then take the write set information and they now put it into the database. If any of the read set elements are now looking different, then such a transaction is declared to have failed the validation check, and such a transaction is then declared to have terminated unsuccessfully. This is why I was saying earlier that the mere inclusion of a transaction into a block cannot by itself be taken to mean that that transaction is definitely going to be successfully executed. The reason the database state could have changed is because while simulation was going on and information got extracted out of the database, by the time this validation comes around, in between, other transactions could have executed which changed the state of the database. And that's the reason that some of the transactions may fail validation. For those of you who know enough about database systems, this is what's called optimistic concurrency control in traditional database systems. And in any case, if you are really into all this, you can go read up more on this. It's a very inefficient way of doing things, because if all the transactions that were submitted in parallel were trying to increment the same value by 1, they'll all succeed in their simulation, but by the time validation comes along, only the very first transaction might succeed, the rest of them will all fail, because the success of the first transaction will cause the value to change, because everybody might have read the current value to be 10, and they all want to add to make it 11. And they all are saying the read set is 10, the write set is 11, and then they get ordered. And then the very first guy, when he goes and looks, the value will be 10, but then he will succeed. He'll now change the value to 11. And then all the other guys who followed him in the block, who are all still looking to see whether the value is 10, will find that it's not 10, and then they'll all fail. So this is a pretty inefficient way of doing things, because if you have conflicting transactions being submitted in parallel, they all get simulated, fine, but at the time of validation, only one of them will succeed in that whole block. And so this is not a good way of doing things, but anyway, that's what it is. There are many implications of this way of executing transactions. In the case of Hyperledger Fabric, they support only the so-called NoSQL database systems. In particular, they supported only a key value store to begin with. The only calls you can make are get, put, and delete, which are pretty primitive compared to a SQL select, insert, update, and delete kind of statements. So here I talk about some of the implications of what will happen if you introduce a relational database system instead of this dumb key value store as the store in which the blockchain transactions asset states are tracked. We do want to support a relational database system because the world has evolved since I started working at IBM 40 years ago, because relational systems have lots of good things going for them from a programmer productivity viewpoint and so on. Whereas some of these other things that came later, the much more recent past, NoSQL systems, are pretty primitive. They're even worse in some cases than the pre-relational systems. But for whatever reason that I won't get into here, they became popular, but they have a lot of shortcomings. This was all a creation of a lot of the companies in Silicon Valley that I'm sitting in. And I'm not happy about this. So I tried to fix this by adding support for relational databases in the context of Hyperledger Fabric. But my project didn't get funded enough in the IBM product organizations. And as a result, the ideas I generated didn't get ultimately commercialized, unfortunately. But there is still scope for some of this to be done. Oracle did do something along these lines in their specialized additions to the Hyperledger Fabric that they haven't open sourced. There are many architectural differences that exist between how Bitcoin and other such systems that came after Bitcoin, Ethereum, for example, execute transactions. They first order the transactions, and then they have to make all nodes that are participants in the network execute them in parallel, and then they cause the database state to be changed. This is where I was saying, if any non-deterministic constructs are there in the smart contract, then when these different nodes execute these smart contracts in parallel, they might wind up with different results. If you, for instance, look at what the current time is, because these transactions are being done in parallel on different nodes and they are not synchronized accurately, only the order is being decided, but not precisely at what point in the real world, clock on the wall kind of time way they'll be executed. As a result, since these nodes don't have synchronized clocks and all that, even if you did that, that might not work. So that's why the smart contracts in a lot of these systems will not be allowed to have kind of non-deterministic constructs. You can't look into the content of a file and things like that. And so be restricted. Whereas if you look at the way I described the three-staged way of executing blockchain transactions in Hyperledger Fabric, you initial simulation where only a subset of the nodes get involved. And based on the result of the execution of the simulations, under certain conditions, if the simulation results agree and so on, then the transactions get ordered by an ordering node, as you see over here. This ordering service, which is a single node in the case of Hyperledger Fabric, which simply orders the different transactions that are submitted to it without going through that expensive mining and such things, and hence the high degree of efficiency of Hyperledger Fabric. And no smart contract execution takes place during this validation step. That's an important thing to remember. Only during simulation, smart contracts were executed. And if there are any non-deterministic constructs, if they don't make any difference, that's okay. Or even if they make a difference, the client could decide, I'll take the different values that come from these different endorsing peers. I'll take the average of those values or the min or max and so on. Some such policy could be defined and still accommodate the non-determinism. And then submit this refined version of the read and write sets for the ordering service to make use of. Anyway, so this is a different way of doing data replication compared to a distributed database. I don't have the time to go through that now, so I won't do that. In terms of where the world is, there's a lot of hype, as I said. There are still no standards. Just like in the relational databases, when they came out, different users were left up to their own devices to figure out under what conditions, what system to use, and so on. Since these permissioned blockchain systems have been around only for the last 4 or 5 years, they have number of features, but they are all different. The only good thing is that there aren't that many of these systems, because these systems have been developed via consortia, and there aren't that many consortiums. And also because they've been done in the open source fashion for the most part, the developments have happened much faster than the way relational database systems evolved. But the problem with this world is that unlike in relational databases when they came out, like DB2, Oracle, and Sybase, and so on, even though to begin with they might have had slightly different APIs, at least the underlying conceptual model was what my colleague at IBM Research had developed, called the relational data model, Ted Cord, that one who got the Turing Award for it. But subsequently, SQL standards evolved, and then of course still different vendors added certain features that were non-standard features. But in the case of blockchain systems, it's not only the APIs that are different, it's also the case that the underlying models are different across these different systems. But unlike in the case of relational systems, these blockchain systems have gotten into production usage as opposed to just production being done much faster. And there are now also attempts to incorporate some of the blockchain-like features, this immutability and using hashing and tamper-proofing and so on, into relational database systems themselves. And there are lots of Chinese companies that are active. I have a lot of reference information that the audience can go look at their leisure. The different research groups across the globe that are active in the blockchain area. We even had Darkstuhl in Germany that I was a co-organizer of, where I brought together a bunch of people from across the globe to, in a more informal way, discuss what needs to be done, what's going on, and try to make some sense of the interactions between databases and permissioned blockchains. This is a long list of how fast things have evolved. The first production deployment happened literally 4 years ago. Very soon after, IBM prototyped something internally and then turned it over to the Linux Foundation, formed this consortium called Hyperledger as a way of community way, in an open source way, in an open governance way, continuing the development of what came to be then called Hyperledger Fabric. And that's now the de facto standard. It's being supported by all sorts of vendors. The concept of blockchain as a service has come about, whereby just like you have software as a service or infrastructure as a service, instead of having to run these nodes of a blockchain network internally in your private data centers, you could actually run them on the cloud. And initially, you had to use the same cloud provider for all the nodes of your network. That's how the IBM blockchain platform really worked. But later on, they have now allowed different nodes of a single blockchain network of Hyperledger Fabric to be part of different vendors' blockchain as a service offering. So one node could be in the IBM blockchain platform, another node could be in the Oracle blockchain platform and things like that. Oracle, the database system, has been extended with a concept called blockchain table. These are what I call the enhancement of traditional database systems with blockchain-like features. The Chinese guys have taken this whole area very seriously. The Chinese president declared a national focus on blockchain innovation. And Hyperledger Fabric has even gone into the second version. This is the first project under the Hyperledger Consortium to have reached that status. There are multiple projects which are even competing with one another under the Hyperledger Consortium so the Hyperledger Consortium goal is not to come out with a single, agreed upon standard system, but to encourage even competing systems to be developed, but in an open source way and things like that. There is also an attempt to now have, similar to heterogeneous database integration, a concept of blockchain integration. Given that there are these different incompatible blockchain systems, is there a way to integrate them whereby a single blockchain transaction could run partly in Hyperledger Fabric and partly in R3 Corda, for instance, which is another permissioned blockchain system, and so on. As I said, the fact that Hyperledger Fabric has a great deal of momentum behind it is reflected from the fact that all these different vendors who have blockchain as a service offering supported. On top of it, there are any number of university projects that are also now doing research based on Hyperledger Fabric. I'm not aware of any other system in the permissioned arena that has got that level of enthusiasm in the universities. Of course, there are lots of people that are cranking out papers on Bitcoin and Ethereum and such permissionless systems. There are many myths associated with these permissionless systems versus the permissioned blockchain systems. Unfortunately, I'm running out of time, so I won't dwell on these things, but you can read in my SIGMOD paper, the keynote paper that I referred to before, the link for which I've given again over here. You will see me expanding upon some of these things. You will hear things like, you know, the permissionless system provides trust in a trustless environment and all that. A lot of these claims are bogus because the minute you have to enter real world information into a blockchain system, somebody sitting in China cannot verify what I am currently to be the temperature outside my bedroom that I'm sitting in. So you still have to have faith in people, trust that's built up over a period of time, just like in the real world. Yeah, you can still have the sleazeballs like, you know, the guy, that Nirav Modi and people like that who do cheat and then they run away from the country and such. But those are less common than any number of cheating kind of people that are hiding under anonymity that the permissionless environment provides. And there are many other points like that that I have here. With respect to this crypto currency, which are like alternate currencies that have nothing to do with you know, governance, as in the case of central bank, reserve bank, and so on. Different countries are treating them differently. El Salvador, believe it or not, made Bitcoin its national currency. They didn't have their own national currency, so for a long time they've been using the US dollar as their currency. But since last year, I think they've made Bitcoin as an alternative national currency. Countries like Slovenia and Austria and so on are now considering taxing cryptocurrency transactions or even capital gains coming from cryptocurrency investments. US is also requiring a lot more rules to be obeyed by crypto brokers. You'll also find, you know, a lot of these crypto people claiming the whole point of crypto currencies like Bitcoin and systems like Bitcoin and Ethereum is to the middlemen and, you know, not trust governments and believe in people to people and a completely peer-to-peer way of doing things. Is also bogus because people can't directly communicate to other people. They all still have to rely on, you know, telecom networks. There aren't too many telecom players. They don't worry about the telecom players doing some sleazeball things. They are also talking about, you know, in the Bitcoin kind of environment where they rely on private key and public key and things like that. People are worried about losing their money if they forget their private key. And as a result, they store their cryptocurrencies in the so-called exchanges. Guess what? Exchanges are nothing but euphemisms for banks. So much for these guys claiming that they don't have any intermediaries. Most of the world's crypto wallets are managed by exchanges, not by individuals themselves. And there are also these attempts now by different countries to create national currencies in digital form. So even the digital rupee is being explored. China, of course, has been doing quite a bit of work in the past few years in what they call DCEP, digital currency electronic payment, which is essentially the digital version of the fiat currency, which is called yuan, also called renminbi, RMB as it's called. And there's lots of that they have done, and China has banned cryptocurrencies like Bitcoin and such. And for a while, they were allowing this mining to go on in China. Even that has been more recently banned because they're all trying to control inflation and also illegal transactions and money laundering and terrorism financing and all that from being done, hiding behind the anonymity provided by permissionless blockchain systems. And Libra is the cryptocurrency that Facebook was trying to create. And they went along for a while and they said that unlike these other cryptocurrencies, Libra will be more stable because it will be backed by a basket of fiat currencies contributed by the members of the Libra Association. But they met a lot of resistance, and even some of the people who had initially joined hands to come up with this Libra Association decided to withdraw. Companies like PayPal, eBay, and Visa, and so on. Later on, and this, by the way, was to be a network where the nodes that execute transactions were to be permissioned nodes that are the nodes that are owned by the members of the Libra Association. But the submit transactions, you and me kind of people, they were trying to make them be anonymous. So it was a hybrid of a permission network, core network, which is surrounded by a bunch of permissionless players like users of Facebook and others who would be the ones that will in an anonymous way submit transactions. This was again something that ran into a lot of issues with government authorities in different countries. And so even, Trump was unhappy about all this when he was the president. In the end, Facebook said they'll have only a stable coin, which will be 1-for-1 equivalent to US dollar. So stable coin is nothing like CBDC, central bank digital currency, but it might be called by a different name. But it might also be issued by other people and so on. Whereas CBDC is fiat currency's digital equivalent. But in the end, the latest news is that Facebook has abandoned the whole project. They completely reduced the initial bells and whistles to something very simple, but even that to have given up on. There are more slides here that I won't go through, which have to do with explaining how Bitcoin works and this concept of UTXO model that is a very stylized, you have requirements, performance, as well as your assumptions about the environment in which you're going to be operating, the happiness of the participants, and so on. I might not want to use a blockchain system. You might want to rely on traditional distributed systems or traditional even centralized database systems to accomplish the goals you have in mind. It's also the case that just because you choose to do things in a blockchain way, it's not like you'll discard everything that you have. There might still be a role for all your backend systems like SAP and so on to be there. For instance, in this scenario, on the left side, using a blockchain mechanism, do your import and export and so on. Order acceptance might be through the blockchain system, but the fulfillment of the order by build something and such might still be handled by your existing manufacturing backend system and things like that. So there may be back and forth communication between the two. And an order comes in, it triggers an activity on the back end for things to get built. And then once that thing has been built, you will then trigger a blockchain transaction. Hey, this order is now, this item that's been produced is now eligible to be shipped. And that shipment and the tracking of all that will be done using the blockchain system. So there are things like that. And also when you have physical goods, one of the problems is, how do you represent the information about physical in the system, in the blockchain, such that somebody cannot later on substitute the physical thing with a fake and still pretend like it's the same as the original thing. You know, replacing a real diamond with a fake diamond, for instance. The technology called crypto anchor verifier that I talk with is very valuable. In addition of a lens to your digital phone, to your mobile, and this attachment can do some fancy measurements depending on what the item is. For instance, in the case of high-end olive oil, it can measure the viscosity of the olive oil so that somebody adds something to dilute it, some cheap thing, then the viscosity will change. Or if it's high-end cotton, then they can use the spectral value. Or in the case of diamonds, it turns out it can take a quote unquote a picture of the inside of the diamond, something like a fingerprint which is unique for different diamonds and so on. So there are many things like that which are also of interest, things like microfluidics and markers on even capsules and such. So there are printed electronics, various things of that nature. So there's an interesting article that I have the link for here, because which will also be there in that National University of Singapore reading list that I mentioned at the beginning, for which you are. Then I talk about from Bitcoin by introducing the concept of smart contracts. Ethereum came into existence, but it still has many of the bad properties of Bitcoin. Bitcoin only dealt with sending around Bitcoins, nothing else. You know, why am I sending some money to RKR? Presumably because he did something for me. He produced some goods or he provided some service. They don't model that. So what if the service he provided was not satisfactory? After I sent the money, I discover whatever he did doesn't anymore, right? How am I supposed to go, you know, or, you know, giving me at least part of the money that I sent him? All of that whole business flow or the, you know, round the full circular thing is not dealt with. Whereas with Ethereum, at least with smart contracts and enhancing what you manage using blockchain to not just cryptocurrency, but also managing any kind of purely digital or presentation of physical things. But it still has this silly things like Ether, the cryptocurrency, and this proof of work for consensus. And they have other things that they have introduced called gas mechanism for transactions and so on. So there are a bunch of things that are still problematic about it. But then other people have worked on, in particular, JP Morgan worked on something called Quorum, which added the permissioned to the original Ethereum, thereby producing a more acceptable what's called enterprise Ethereum. But it has variations to Hyperledger Fabric. So there's more of it here about how Hyperledger has evolved and how it's still evolving in terms of the roadmap and so on that I don't have the time to go through. The Corda, in contrast to Hyperledger Fabric, is the creation of a consortium of financial institutions. It turns out as a result, they made certain elements that are part of their conceptual model, their system, their APIs, which are concepts that are generic to financial industry. Things like cash contract, bond contract, and so on, as well as keeping track of notion of notaries and regular transactions. So this is where what I meant when I said at the very beginning that not only are the APIs different between systems, even the underlying conceptual models are different. In contrast, for instance, in the case of Hyperledger Fabric, it's extremely modular, but it's simple stuff that comes with the system. If you want, you can build on top even concepts like cryptocurrencies. And there have been implementations like that even on top of Hyperledger Fabric, but the base system itself is considered to be very flexible and modular, where you can substitute some things. If you don't consensus mechanism, you can replace it with a different consensus mechanism and so on. There are other things that I just don't have the time to go through now, since I'm already way beyond the time. And Financial built its own blockchain. This is the subsidiary of Alibaba in China that was trying to go public with the Chinese government. But they have introduced concepts like within a network for a particular purpose, you can still have public data versus private data, because some of the data might be so important that only a subset of the nodes work should have visibility to it. They also have the concept of smart contracts having two kinds, public smart contracts and private contracts. So they have a different way of executing these sensitive information management for the private data and also the confidential contracts using what are called secure execution enclaves. Intel has this in the hardware. You can do certain things that are highly carefully done that nobody can muck around with. Even the operators of the systems cannot do stuff. Execution of doing things. SAP, meanwhile, came up with their own APIs, and they said if you use their APIs, then you can dynamically change your mind about what the underlying blockchain system is in which application will run. This is in a way similar to if you are using SAP R3 and using BAPL, their language, they allow you to dynamically change the backend database system from DB2 to Oracle, for instance, because you are using their API. This is like object relational mapping, right? You use some constructs in J2EE, and then they get mapped within the J2EE app server to the underlying database system. In a similar sense, here they are saying, if you have faith in API having longevity, and you will get independence of the underlying blockchain platform. Smart contracts themselves, as I said, there are different systems with different requirements with respect to what language you code them in, what primitives you are allowed to use. It cannot be a Turing complete programming language because of the non-deterministic constructs getting you into trouble, as I explained before. So there are also people now talking about making smart themselves be portable across, for instance, these systems called Besu, Fabric, and Sawtooth, which are systems that are under the Hyperledger consortium. And so they talk about portability contracts across blockchain systems. Hyperledger Cactus is a blockchain framework. I very briefly mentioned it at the beginning, that the idea is that just like you have heterogeneous data integration in the database context, how do you now allow a single blockchain transaction to span across heterogeneous set of blockchain systems? So here, talking about Hyperledger, Besu, Corda, and Quorum, how to execute these operations across these things. And then there are benchmarks being developed. Some initial attempt was made at the National University of Singapore in their Blockbench project. These are attempts to do like what was decades ago in the database space, the Transaction Processing Council benchmark, TPCB, TPCD, and so on. They are trying to do similar things here. In the Ledger Consortium itself, there is a project called Caliper, which is intending to do this. They are also developing tools for doing performance evaluations. These are the sorts of things that are over a long period that have gone on over decades. In the case of the relational database arena, tools and methodology and guidelines and such that got developed by not just the database vendors, but even other companies and university people and so on, that made it a lot easier to use database systems. You need similar things in the blockchain space for these sorts of systems to be more usable and easier to compare one another with and things like that. So I think I'll stop here. Here are a few things that people are working on, how to allow cross-channel transactions within the blockchain system Hyperledger fabric. You can subset the nodes within a network and create what are called channels, so that if you have two different supermarket chains sitting within the same blockchain network, they might want to hide interactions with their suppliers from each other. So Walmart wants safe way to see what kind of traffic Walmart is generating with its suppliers, because this is considered competitive information. So you can form a channel, which is like a Venn diagram, where some nodes can have their own blockchain and smart contracts and such, while still having overlapping channels and such. So there may be times when Walmart and Safeway are actually working together, but there are other times when they're working with one another. This is similar to the co-opetition concept. And then there are other things like how to more formally talk about correct contracts and things like that. And track my activities over time. I keep evolving these papers. Some of the slides I showed you today, didn't have them when I gave the talk a few weeks ago for a conference in Coimbatore. But if you follow me on social media, or at least look at my my spreadsheet, for which the link is here, the CM Talks, for which you see the QR code here, you will be able to find out about my presentations. And as I said, there are many other videos and such I have with the corresponding PowerPoint slides. I welcome you to listen to them, and you'll also hear Q&A by people in Amsterdam and various other places where I've given the talk. Thank you so much.
Thank you, sir. We'll quickly have a Slido and then we'll have a Q&A.
Okay. Should I do something to give up control, or?
No need.
Okay.
Participants, I have shared the link in the chat box. Please register for the Slido quiz. I'll share my screen. Okay, start the quiz. Okay, we'll start that. Your first question. Which is the most popular permissioned blockchain system? You have a 30 seconds.
Boy, people miss the point about permissioned.
We'll go to the
Ethereum
next.
is permissionless.
What is a stable coin? This is a test they have learned watchfully, that is closely watched that presentation and that. You have 5 options. Let's see how many people have answering correctly. Okay, 21%. Let's see.
Well, okay. I mean, A could be thought of as an answer, but really, fiat currency's value could change vis-a-vis some other currency. So in that sense, B is a better answer.
Have a third question. Cryptocurrency is essential for the functioning of a blockchain system. Four seconds to have yes answer. No.
This is also bad. I told you, Hyperledger Fabric doesn't even have a cryptocurrency.
We'll see the next question. What is Hyperledger? Let's see the answer for this.
Again, a problem. It's the consortium name. Hyperledger Fabric is a system. Hyperledger itself is the name of the consortium.
Yeah. Next question. A ledger is. This is quite interesting. The answer. Ledger is. Okay, let's see the leaderboard. Okay, Dr. O. Prasanna, Jivita, Ashok, Usha, and Mercy. Yeah, let's see the sixth question. Which was the first country to make Bitcoin one of its national currencies? Okay. Let's see how many people are answering correctly. Good to see. Okay.
Oh, good.
Yes. Which country banned cryptocurrencies and blockchain mining? This is also interesting. Okay.
Good.
Yes. Eighth one. This is also interesting. This thing has come, had come in the presentation, in your presentation.
Oh yeah. Remember I talked about how it was awarded to KPMG.
Okay, let's see.
Yeah,
Yes.
people got it.
9th one. Which company played a fundamental role in emergence of Hyperledger Fabric? IBM.
All right, good.
Final question. R3 is the R3 is the consortium of
Good.
right. Let's see the leaderboard. Okay, congratulations to Willy and Ashok, Dr. Prasanna, Professor Anand, Professor Tirumurthy. Thank you. Thanks for the participants.
Congratulations.
Thank you.
Oh, all of them got 7 out of 10. So it's now based on time. I see.
Time, yeah. It is based on time. Yeah.
Interesting.
Okay.
So
Thank
nobody
you.
got 10 out of 10, huh?
Yes. I think we can go for the question and answer session.
Okay.
Yeah. Any questions? 1 or 2 questions? Quickly. Anyway, it is around 10 o'clock in the night for the speaker. You can.
Hey, it's 10:03.
Yeah, 10:03. Yeah. Share few research areas in blockchain domain.
Yeah, I know. I listed a few in that last slide, last but one, allowing for interoperability. Some of these are being explored by some of the projects in the Hyperledger Consortium. But things like atomically moving something from network to another network, these are applications on actually traditional database problems like two-phase commit when you are doing a distributed transaction. There's also this issue, as I said at the beginning, of support relational database systems in Hyperledger Fabric. I had a project that I was doing that then didn't get picked up by the product people in IBM. I had not fully figured out everything. We had done a bit of prototyping because the simulation concept becomes problematic the way it's tracked today in Hyperledger Fabric. Layer above the database system is tracking and write set. That's done easily if it's a Mickey Mouse API like get, put, delete or a key value store. But the minute you have SQL as the lingua franca between the smart contract and the database system, no longer that easy to figure out what the read and write sets are, because in SQL, even what appears to be an update statement also does reads. Insert from subquery or update where some condition is true. You have to now split that statement into two. The read alone needs to be pushed into the DBMS. The write part has to be still tracked on top. And there are other complications that come from what are called the phantom records and so on. If you have a range predicate, you would have to re-execute that range predicate at the time of validation. You cannot just look at only individual items values to see if they've changed or not. You have to actually re-execute the query and see is the result coming back for the query the same as the result that came back at the original time, which is much more complicated. And so some of this I mentioned in that slide I showed about database implications of this way of doing blockchain transactions. There are many performance related issues that people have been working on. Let's see, share few, okay, supply chain with block search perspective. There's lots of work going on in that space. There are many implementations also. So I don't know if there are very specific research ideas as such specifically in that arena that I can think of right now. How to scale the Hyperledger logs. I don't know what this person, Tirumurthy Nanda, is referring to as the Hyperledger log. I need to find out from him what he means by log. Are you referring to actually the blockchain construct itself, or you're referring to something else? I think that's it.
That's it. I request Mr. RKR, Mr. Ravi to pitch in for final things.
Again, go take time to look at my presentations, and so again I'm posting the link to that spreadsheet which has tons of information, and I'm adding more things to it. There are other presentations that some of you might be interested in that I haven't yet listed there. Okay, thank you.
Thank you,
go ahead.
And Ravi sir. I request Mr. Ravi, Mr. RKR.
I thought somebody came just now for a second and then disappeared.
One second.
Oh, Ravi, okay.
Ravi,
he's frozen.
Okay, fine. Right now, yeah, RKR, you want to do the honor of vote of thanks?
Yeah,
I'll do it. I was muted, so I could not speak.
Yeah. No problem.
Yeah, I know. I was also muted. Anyway, yeah, okay, then carry on.
Okay. Thank you, Mohan. I'm sorry, my network has failed and I'm speaking from my mobile phone, so I may not be very audible.
Yeah, you are fine.
Okay. So thanks, Mohan, for your excellent session. We are been enlightened quite a lot on the blockchain concepts. You covered the concepts very well with parallels to the database recovery, which was very interesting. And we learned quite a lot. It was very useful for most of us to learn about it. And then you talked about different flavors of blockchain and how it is being applied in different aspects of life. Incidentally, I don't know if you mentioned it, but I might have missed it in the network, but one of my acquaintances is also using blockchain in the pharma industry for doing pharmaceutical testing, for facilitating that. Just for information.
In fact, in the hidden slides, you will see some of those sorts of applications being talked about. Even with the Food and Drug Administration in the US, IBM did some stuff. Yeah, there are wide-ranging set of topics in which blockchains are being used, actually. Right.
So it's a very upcoming area, and there's quite a lot to be learned. And your session was really a great eye-opener for all of us, who also incidentally will get access to a lot of material that you are indicated that you're sharing with us. I'm sure that will be also very useful for everyone to learn about the concepts and details of blockchain, which probably many textbooks also may not be giving to in such level of understanding. So thanks for spending your evening or rather getting late into the night for taking this session. And on behalf of PALS, I thank everyone, including the participants, the organizers, and I especially Mohan for this excellent session. So we'll conclude with this, and thank you everyone. Good night, Mohan.
Yeah, thanks for organizing this and inviting me. I really appreciate it. And thanks for all the help, Robin, and the rest of you for introducing me
Thank you,
and
sir.
around
Thank
for
you,
so
sir.
long. Bye-bye.
Bye.
Have to describe your transactions, even sending money. Mohan sending 5 Bitcoins to RKR, they'll try to see whether Mohan has the 5 Bitcoins. So if I happen to have actually 10 Bitcoins that were as a result of 7 being sent to me by Robin and 3 being sent to me by Ravi, then I have to now explain, if I'm taking out only 5 to send to RKR, I have to now create this model in which I now send 5 to his node, which will become the input to his transaction. And I have to send remaining 5 of the 10 that I own to another node, which is like my own wallet. And later on, use that to pay somebody 2 Bitcoin. So it's a very painful way of doing things. It's not like you keep a balance and in parallel you can submit multiple transactions and so on. So there are lots of use cases that have been worked on over the last many years across different kinds of vertical segments of society. They are not only in finance, but also, for instance, in insurance industry. This is a production deployment that happened way back in 2018 using Hyperledger Fabric, where there are multiple insurance carriers who are all working with one another and making information available to each other for regulatory purposes and all that. I've even seen something where somebody might drive from one country in Europe to another country, and then they have an accident. So multiple insurance companies might be involved, and they have to exchange information. They want to do all this in an efficient way, in a trusted way, and in a tamper-proof way. So things like that. In this case, for instance, large carriers can save millions of dollars in annual reporting by making use of kind of blockchain network. I found out there may be some players who are insurance companies who can't have their own individual in this network. In that case, this association, American Association of Insurance Services, it provides a node